My name is Peter Holper. I'm an application scientist here at SCIEX. Over the years, I've worked in biopharma for quite some time, worked in analytical development, supporting a lot of different products, therapeutic proteins, fusion proteins, mAb proteins, insulin products, really helping those therapeutics come to market and supporting analytical development. So today, really excited to talk to you and invite you into my lab right here in Redwood Shores to learn about our lightning CESDS method for protein purity on the new SCIEX BioPhase 8800 system right over here to my left. So today, we're going to go through that lightning CESDS workflow. We're going to look at how it can be set up, analyze both reduced and non-reduced samples in about 5 or 6 minutes per sample. And the big thing is going to be we're not compromising any data quality here. First, we're going to start with an overview of the BioPhase 8800 system right here. And we're going to take a look at the touchscreen. So here, we can see the touchscreen on the BioPhase 8800. We see a few different tiles. And each tile gives us different control over the instrument. So if we click this first tile, this direct control tile, for those of us that are used to 32 karat or even in power controlling our P800 Plus systems, these are look very familiar, much more graphical. So we can still do all the same manual things that we're used to be able to do. So manually setting our capillary or sample garage temperature, doing manual rinses, manual injections, manual separations. This is also where we can manually eject our sample trays, eject our reagent trays to load those in. We can look at cartridge info, which is something that's new. And we'll also be able to load and eject our capillary cartridge. On the top here, we can turn our lamp sources on and off through just a click of a button. And what is also nice about the BioPhase 8800 system is both the UV lamp and the laser are on board at all times. So there's no more switching out detectors or optical sources. Now, if we look at that cartridge info, we can get an idea of what we see there. So our cartridge info, the BioPhase 8800 cartridges do have an RFID chip that in it contains the serial number, lot number of the cartridge, capillary length, type of capillary, number of runs that it's been used the first time you use it. So everything is really captured on the cartridge at all times. There's no more paper logbooks that you need to be working with. If we go back, or we go back to our home screen, we have a few different tiles down here. Our next one is our run sequence tile. When we create a sequence on our BioPhase computer that's sitting next to the instrument here, we can create our sequences. And when we save that in a certain project folder, you can just navigate right to there when we're ready to start our run. We'll be doing that a little later today. And the last one we're going to take a look at here as far as tiles go is our capillary view. Click on that. Go to view all. Here, as your run is going, you can see a real-time view of all 8 capillaries. These are all 8 individual independent capillaries. You can tile them here. You can overlay them into a single view. You can check out the generated current. You can go to a mixed view where you have your optical trace as well as your current trace if you so choose. On the bottom, we can see exactly what the system is doing at any time. So let's see, the system status currently is just idle, how far it is in any of the rinse actions it's doing, type of method it's running, the sample temperature, cartridge temperature, applied pressure, applied voltage, generated current, et cetera, et cetera. Here, we take a look at our capillary cartridge. It's going to look a lot different than those of us that are used to the P800 Plus system. We have 8 individual capillaries here on our inlet side. Each one has its own independent electrode, and we can see all 8 capillaries are going through. Here we have our detection window, and then on the outlet side, they're all bundled together. So it's still 8 independent capillaries there, all 8 independent outlets, but all in one location. On the outlet side, the electrode is positioned right next to it. On the inlet side, these have 8 individual electrodes. You might also be able to see a little plastic partition here for a recirculating liquid coolant. So this cartridge still uses our recirculating liquid coolant to maintain that robust sample temperature control so that you do have nice reproducible data. Now, what is nice is that the window for all 8 capillaries, there's no more aperture there. You don't have to change it going from UV to LIF or anything like that. It is really easy to use, plug and play. We flip this over, we can see 2 O-rings here. This is where our recirculating coolant is going to go in and out of our cartridge. And to the side of that, you have 2 circular O-rings, and this is where the pressure is being applied. So our interface block is actually interfaces to the side of the capillary rather than the bottom, which is a little different than the P100+. But what we did there is we no longer really have to wipe down that interface block in between runs. So we've engineered out a lot of that user involvement, a lot of that user cleanup. Right here is our RFID chip. That's where all that sample information or cartridge information is stored. You also have some of that same information up here, the type of capillary, of storage condition, part number, etc. We can put that away. Next thing we're going to look at is our plates. So the BioPhase 8800 is a 96-volt plate-based format system, but it has some unique plates here. So on the bottom of my hand, you can see our reagent plate. A reagent plate has 8 individual reagent wells for 8 individual capillaries. So each one is going to have an independent well that it's sourcing from so that we maintain independent injections. Now our outlet tray has 1 trough because all 8 capillaries on the outlet side are going to be going into the same well there. And the capillary kind of fits like that, right over the top. So it creates a nice pressure seal, allows you to do electrokinetic or voltage separations, also allows you to apply pressure for either the injection or for your rinse steps in between injections. And then we take over here, we have our sample plate as well as another outlet plate. Our sample plate, 96-volt plate-based format again. We do have spacing that allows for pressure injection for those of us that like that in our CESDS assays, but also, certainly can do electronic, which is our standard mode of injection. And then it just has an independent outlet plate there. Now we'll notice that each plate has this little notch or this angle, this 45-degree angle at the top to make sure that when we load it onto the system, we're loading it correctly. And for the reagent and sample plates, they have little notches or keys on opposite sides to ensure that we put them in the right spot. So if you try to put this one, this reagent plate where the sample plate should go, it's not really going to let you because the notch is not going to fit on that side. So here is a look at our CESDS kit. You'll notice that we have a lot of different colors going on. So here we have our basic wash with a blue cap, our acid wash with a red cap, our gel buffers with green caps, waters, sort of this opaque cap, and then our sample buffers down here, both are low pH that we can use for our non-reduced analysis, or our standard pH 9 buffer we can use for either one, our reduced or non-reduced. Now, we'll also see that even the boxes are color-coded. So here we have the orange box, that's color-coded for an ambient storage, green box, color-coded for a refrigerated storage. So everything is very color-coded. Now, as I mentioned at the beginning, all these caps have different colors. This is going to correspond to our reagent file in the BioPhase 8800 software. So when we're loading our reagents into our reagent plate, they're going to be color-coded. So where we load our basic wash is going to be color-coded blue. Where we load our acid wash is going to be color-coded red. Where we load our gel buffer is going to be color-coded green. Very nice concept that I enjoyed seeing and have thoroughly enjoyed using when I've been playing around with this piece of equipment. Now for our sample prep, the sample prep that we're going to look at today is we're preparing our sample, in this case in this mAb, down to about 1 mg/ml for both reduced and non-reduced. For our reduced, we're adding a slight amount of beta-mercaptoethanol, about 5%. And for our non-reduced separation, we're adding a small amount of iodoacetamide to ensure that we do not have any bisulfide scrambling taking place. So the BioPhase 8800 system is a little different. Actually, it's a lot different than any other chromatography data system software that I've used in the past. It's a lot different than 32 karat, a lot different than Empower. And one of the things that we start off different is our reagent editor. So reagent editor is where we actually define what reagents we're going to be using. We open up one of those reagent files, what we can see is we have to define all the reagents that are going to be used on our inlet or outlet sides for our assay. And as I mentioned with that color coding, you can see here for our basic wash, we color code it blue. For the acid wash, color code it red. Water, we color code it just this nice sky blue color. And then the gels, we color code green. And then on the outlet side, we have the same thing. Our waste color coded black, our gels still green, and our water dip for blue. So what is nice is that, well, the color coding is very nice. And you really just put in anything that you're ever going to want to use on the inlet side of your reagents or the outlet side. So it's no longer a static position like you used to have with the P800+. Now everything is becoming more dynamic with this software. Well, the method editor is also very cool. Let's go ahead and look at the methods. We can see the big differences between the Lightning CE-SDS method and our standard methods. Here we're going to look up and start with our standard CE-SDS method. So in our method program here, in the method settings, you can see where we can designate a lot of the same options that we had on the P800+ 32 karat system, as well as those reagents from that reagent file that we had previously created. So in the method program now, we can see exactly what the system is going to do. And in our standard method, we have quite a bit of rinses. So we have about 7 minutes, 10 minutes, 15, about 25 minutes of rinses between our basic wash, acid wash, water rinse, and our gel rinse. About 25 minutes before we hit our water dips and we start to inject the sample. Now, what we wanted to do with the Lightning method was see how far we could take this down. So how could we adjust the pressure in the rinses? And do we really need them to last so long? But what we have to ensure we don't do is to sacrifice any robustness of the system. So if our data quality was sacrificed, or if we have any carryover or anything like that, certainly we can't move forward with that. That's why we've gone ahead and done all the testing for the Lightning method for you guys. Now let's take a look at that other method. So we look at our shorter Lightning reduced method here. There we go. I can see we had about 25 minutes of rinse time with our standard method that we first launched with the instrument. And with our Lightning method here, we're at 2, 4, 8, 9, about 9 minutes of rinsing. We come from 25 minutes down to 9, so about 16 minutes of rinse time that we've shaved off there. We have a total method duration here of about 34 minutes, and that's for 8 samples. Right? That's not per sample. So one of the nice things about the BioPhase 8800 system is you get the same data quality that you had on the P800+. On your P800+, and some of us have gone to shorter rinses on the P800+, but we're still just doing 1 sample at a time. BioPhase 8800 system, you're doing 8 samples at a time. So even though we say, okay, yeah, that's 34 minutes, it's actually 34 divided by 8. So you're looking at, under 5 minutes per sample, getting quite close to about 4 minutes per sample. But if we swap over here to our non-reduced separation, that's about a 65-minute separation with our standard method at the launch with the system. And if we go down here to our Lightning method, there we go. Now we're down to about 44 minutes. So again, we're shortening it by over 20 minutes a sample for this particular method. And the majority of that is all just around here in the rinse time. So we do shorter rinses, we do potentially higher pressures, all to really just speed up this whole process. We originally probably had a more conservative approach to those rinses, but now we're really analyzing up to about 1.5 times faster than what we had before. What is very important to everyone, actually, let's go to the sequence. So now we can open up our sequence. because I love the BioPhase software. I love the drag and drop. If we go to our sequence, we want to open a sequence here. We have our 96-hole plate in the bottom left corner. We have the well locations of where our samples are located. Let's do something like this. And then when we want to run a method, all we have to do is take this method, drag it down. We see that the column there is highlighted, and then it will populate over here on the right side. So we can do our non-reduced, we can do reduced, we can do reduced again. We can switch back and forth between UV and LIF. The BioPhase system can do quite a bit. Now, one really cool thing I like is in this plate layout. So the plate layout will tell you exactly where your reagents are going to go. And what I think is very neat is this is no longer static locations. So what you can do is move the location of your reagents around. And you kind of see how I like to do it. I like to have all my waters there in the front, and then have my basic acid wash, and then have my gel also together in the back. And then you'll see the different water dips or waste locations in this outlet reagent plate. So I think this is really cool. Everything is color coded there for you. You can take a screenshot of it with your phone. You can print it out, take it into the lab, set up your plates, load them onto the system, which we will be doing now. So now we can switch over to looking at those reagent plates that we have, loading them onto the system. So right here, we're going to go back to our direct control screen. We're going to eject the sample. Then you can sort of see this partition here open up. Or you can take out, your old sample plate and reagent plate. Take your new one. Just pop that right in there. Pop that down. Click the button there on that front panel. You'll see the partition close. And as it gets it into place, just wait for that there. Now we can eject our reagent plate. Now reagent plate is stored in different part underneath the system, so it's just going to move that over to our little partition here, our little garage. It takes about 10-15 seconds here. It's almost done. We can actually see the percentages of how close it is. Now it's opening that up. So now we can take the reagent and outlet plate that we have here, load that in. So we do that, we load our reagent plate, click that button, closes up, and that's ready to go. Now the next thing that we want to show, we're going to switch back to that front panel view, because I forgot to show you guys this before when we were going over the front panel. Where exactly is the cartridge stored? So on the BioPhase 8800 system, we just slide this touch screen over to the left, and on the top middle, click a button. The cartridge becomes ejected, or it no longer loads in. So right now it's ejecting our cartridge. And then once it's fully ejected, I'll be able to pull it out. You guys can see just how easy it is. It slides right back in. So here, I'm just going to pull this cartridge out. Just like that. Put it back in. Slides right in there. Press the button. It's going to relock it. See this arrow going back as it pushes the cartridge back against the interface block. And then we'll be ready to start our run. So now that it's loaded, we go to run sequence, bring open our lightning sequence here. I think it's kind of neat. So we've loaded our sequence from our project folder, and we have a lot of different options here as well. So if we click on that reagent icon, it'll give us a zoomed view of exactly where your reagents are. If you want to take a double check, make sure you put everything where it should be. You click on the sample location, it'll show you exactly where your sample should be loaded. you click on your method, for example, it'll show you exactly all of the method parameters. So the rinses, the wait times, where it is, and as it's going, it will tell you what part of that method it's on as well. So once that's all ready to go, you just hit run sequence. And now we can see that everything is running. So it's going to start with that conditioning method, go down to our Lightning CSDS methods, and finally do our shutdown method as well. Take a look at capillary view again. I think for now, we don't need to wait for those samples to run. We can jump back to our BioPhase software where we can look at the data analysis. So we launch this data analysis, actually. Go to this one, open that up. And we're going to look at our 8 reduced samples here. Open this up. So this is sort of how you load your samples. When you, in your sequence file, you're going to say, or you're going to choose a file path for those data files to be saved. And when you're ready to go and analyze that data, you can just navigate to that file path wherever you have it saved, open it up, and the BioPhase software will go ahead and analyze it or bring it up sort of into review here. So let's see what we can do. So this already opened up with some settings, but what we want to do if we didn't have any settings at the beginning, we're going to go ahead and do is enable what this calls the optimizer. So the BioPhase software comes with this optimizer, and you can see some different parameters and values here. We want to start with the system trying to gain a minimum signal noise ratio of 10. So our limit of quantitation there, signal noise ratio of 10. And then the default noise interval size is 50. So we go click that. We can see this turns green. And then up here on this upper right-hand side, we see parameters modified. And click this play button. For those of us who might remember a Sony Walkman or something like that, click that play button. And then it'll go ahead and analyze it based on those parameters. Now we zoom in a little bit, we can see this gray line. This gray line is called a positive threshold. And what that means is it's sort of like a minimum peak height for any samples to be caught. So what I might want to do is come in here and change some of these parameters. I'm going to change the peak width. I'm going to change this positive threshold. And what is also kind of neat with BioPhase software is it gets a value. So you can do both percentages or raw numbers if you want. We'll see how 4 looks. And then we have some user parameters that we can enter here. So we're going to suspend the integration for the first, say, 12 minutes. We're going to suspend integration, say, for the last 2 minutes. Hit that play button, see how it goes. Positive threshold, still a little bit too high there. Bring this down a little bit. And you can see that as I change it, this gray line comes down. And as the peaks cross above that gray line, they are now considered peaks. So we kind of want to get these last couple of peaks here. We might bring that down just a little bit more. See how that does. So there we go. Now we could probably play with this a little bit more. You can see we have our 10 kilodalton marker here is in green. We have our light chain there in blue. Non-glycosylated heavy chain there in blue, or heavy chain there in blue. Now we see this little back shoulder peak. I could probably optimize these values a little bit. And I'll try this peak width really quick just to see if this does anything. Nope. Okay. Well, it doesn't, but yeah, it was worth a try. But what is really nice in this software is you have what they call these anchors. So if we hold down Control and left click, we get these 2 anchors. We right click, and then we have a lot of things we can do. We can delete peaks, add peaks, merge peaks. We merge those peaks together. Yeah, it's all gone. So we've got a nice looking set of analysis parameters here that I'm going to check all these other data files. And if I right click on here, I can apply these parameters and analyze all those checked data files that I just did. Now we're going to see how those look. We have this 8 peaks, this one's at 9 peaks. So if we zoom in, we can see that this peak, still split out for that sample. Really not a big deal. I mean, if we look at it, the corrected area percentage is about 0.16, so very, very minimal. But if we want to, we can just go ahead and merge those peaks back together. And take a look through it, how it did for all of our samples. We can also click this button here and bring them all into an overlay. Now over here, because we do have a 10 kilodalton marker, we can switch between raw migration time and sort of this calibrated migration time. So you can use relative migration time with this software. It's very easy to use, very, very handy tool. You're running CIEF, you calibrate your PI markers. On SCIEX, you can calibrate it by an internal standard if you so choose. You can change the zoom there with that setting. But what is really important to know is that look at our 8 capillaries and look at the really everything looks almost identical as far as the profile goes. So all 8 capillaries, we have this light chain back shoulder. We have great resolution. Here we can see our thioether linked half antibody, our 10 kilodalton markers up here. And if we look, one of the nice things about this overlay in the software is we can get some very simple calculations. Maybe not so simple for a person to do, but for software to do, it's sort of what we come to expect. So we can see RSDs for our named peaks here. This is standard deviation. You can see min and max. Here's our light chain peak. RSD about less than 1% for migration time. For corrected area percent, it's about less than 0.3. Look at our non-glycosylated heavy chain. RSD for migration time again below 1%. Corrected peak area a little bit higher. Because we didn't merge the back shoulder peaks for all of them. We only did it for a couple. Actually, that was a non-glycosylated. Excuse me, I misspoke there. But then, when we look at our heavy chain, we have the same thing, right? So we have very reproducible migration times, very reproducible peak areas with our lightning method, and it's all getting that result much faster than you would otherwise. So again, we're talking about less than 5 minutes per sample for this reduced analysis. Now, we can save all our data files. We can save our workspace, which is sort of our processing method parameters. We can print these results into a report if we choose. There's a lot of different things. It's a full chromatography data system, so no stone is left unturned. So now, actually what we'll just do, we're just going to open up our non-reduced data. So open up these. Now we don't want the reduced data anymore, so we can just click those buttons to very quickly get rid of those. And let's look over here. So we're going to go back to our optimizer. We're going to enable that, click OK, click the play button, see what it does. All right, so here you can see sort of what it thought of everything. Again, it integrates a lot of the system peaks, the buffer peaks. So we're going to start with suspending that integration from say 0 to 12 minutes. And then from say 31 minutes out. Now we can change some of the other ones. So I end the peak with about 200. It's usually where I put it. Positive threshold looks pretty good. We're picking up some of the peaks there. Cluster distance, maybe we want that a little bit wider. See if we can. Oh, that helped us get our 10 kilodalton marker all together. Again, what we can do with this back shoulder peak, we can play around with the parameters, or we can just merge those peaks together. And once we like it, we right-click, apply, and analyze the check. And we can zoom in. We can actually apply this zoom globally with this button. It's a nice little feature there. And go ahead and merge some of these peaks together. Do the same here. Oh, yeah, you can just do a quick look through to see what you got, and you can make adjustments as needed. Now, if we look at the overlay, because again, what really matters is that we're getting the same, whoops, I have to add them to our overlay here. What really matters with this assay is ensure we're getting, that robust result, right? That we're making sure everything looks the same across all our capillaries, that we're getting what we're used to seeing. If we look at corrected area percent for the main peak, about 97.5%. Pretty tight range there, even for not really going through and making sure all of our peaks are integrated exactly the same. We're also very close to what the mAb C of A is telling us that it should be. But if we look there at the overlay, all 8 capillaries look very nice together. Zoom in a little bit there. You can see all our free light chain there. Heavy light chain most likely there. Not too much going on in the region of the half antibody. A little bit of this 100 kilodalton form. But all in all, that looks pretty good. I think we've gone over, how you can easily analyze that. In this library tab, this is where you can choose your marker, your 10 kilodalton marker. You can exclude it from the peak area, which is nice, so that you're not arbitrarily adding this into your peak area, because that's not part of your sample. Down here, you can add different peak names, change this to intact as you see fit. Do what you want there, analyze that data. And you can also do some things in the post-analysis. You can set system suitability parameters to show you which might have failed. If you're looking at, say, main peak, corrected area percent has a min value. So you might say this main peak has to have a minimum value of 95%, otherwise it's going to fail. You can do that. You can have it merge peaks. So if you always want this peak to merge, you really couldn't get the analysis parameters to get that together. You can just say, hey, I want you to merge the peaks from this migration time to this migration time. And the software can do that for you. So a lot of unique features in this software that I've grown to like. I do a lot of my data processing and import them into this software because it is very user-friendly.